Well then, some interesting activity, including a possible Earth-directed coronal mass ejection, huge filaments, a major uptick in the radio flux, and lots more to cover today. There's the northern hemisphere, and you can see a crown prominence up there. It is actually mostly collapsed now. We'll show you a more up-to-date image on that. That's a 24-hour video from the Solar Dynamics Observatory. Here's a little closer view of that crown prominence. Crown prominences, they are a more common feature to see at solar maximum, which means as we approach solar maximum over the next year, you can expect to see more such features depicted at the Smash News Network least busted name in news. Largest event of the past 24 hours was an M2 class flare, which you can see up there to the northeast of the Earth scale, right there. And multiple coronal mass ejections have been occurring. We'll also cover a fantastic article reinforcing what we've said repeatedly on the channel, that solar flares don't cause coronal mass ejections. Coronal mass ejections cause solar flares. Check out the filament there to the west of the Earth scale. That is one of the largest and densest plasma filaments that we've ever had, and it's moving right into the Earth strike zone. So if that thing releases at the moment, that could produce a huge earthly directed coronal mass ejection. And let's briefly zoom out, and I'll show off my magic shirt. Pardon my magic shirt. It's a color that my keying doesn't like, and I'm not changing the keying just because of my shirt color. So anyway, these are all 24-hour videos from SDO. That's 304 plus 193 angstroms. And by the way, thanks for tuning into the Smash News Network least busted name in news. And by the way, we've got some more fashion advice for you here. Today's featured product from the Red Bubble Shop is, and by the way, save 40% site-wide with the promo code You Deserve It, because you do. And you deserve to stop believing NASA's lies. When are you going to stop believing NASA's lies that Earth is an oblate spheroid? What kind of an idiot believes stuff like that? Everybody that watches our channel is smart enough to know that Earth is croissant-shaped. So, I mean, duh. There's a real image of the Earth. Taken by private astronauts in the 1980s. I know you've never heard of them. That's because the government suppressed those images. But we dug some up. Earth. It's shaped like the French breakfast pastry, you idiots. Not a pizza, like you flat Earth noobs claim. And not like all of you astronomy noobs who are like, oh, Earth is shaped like a sphere. It's shaped like a croissant, dummies. Anyway, save 40% site-wide on our Croissant Earth Society products with the promo code You Deserve It, because you do. You can also find other paid affiliate/sponsors in the description below this video, so help keep this channel in existence, publicly visible and free for all to view. We don't want to put all the content behind a paywall, so help create the likelihood that this channel will continue to exist, remain publicly visible and free for all to view by shopping at our Hemp Lucid shop. Perhaps pick up some body balm, CBD lip balms. They make great gifts, by the way. I like the vanilla. Even CBDs for your pets. The Delta 8 products there, like the dissolving oral strips. THC-free products. The most popular are the CBD tinctures, especially the water-soluble. If you want a longer duration and a longer onset time, pick the MCT suspension instead of the water-soluble. Links to the Hemp Lucid shop below the video and on the homepage at smashomash.com. And welcome to the Neo Renaissance, by the way. Congratulations on realizing the channel exists. We remain surprised, and my shirt is full of space. That's the constellation Cygnus behind me, by the way. That's the galaxy Cygnus A right there. The second strongest radio source in the entire sky, second only to the closest star. El Sol, Helios, the sun. Smashomash.com is where you can find our links. We launched it back in 2019. So visit our links, visit us on social media, etc. Today's featured product is in the Spaceware collection on the Amazon store. It's amazon.com/shop/smashomash. And the featured product today is the shirt that I was wearing yesterday The King Kamea. I got so many compliments on this shirt that now we're telling you, hey, if you want that shirt for yourself, just look in this Spacewear collection at amazon.com/shop/smashamash. And by the way, the commissions that we earn there are tiny. So it's basically just a shopping list to help out people like you. Like the creation of these videos, we make almost nothing for that Amazon shop. Anyway, here is yesterday plus today in SDO intensity gram. And again, the largest flare event was indeed from this sunspot group up here. And the likelihood of major solar flares remains really across the entire northern disk. All of these groups are capable of producing large flares in terms of their magnetic field orientation. There is the magnetogram for yesterday plus today. That is September 7th and September 8th to date. Let's see what's going on with volcanoes. And interestingly enough, Campe Flegrei has shown the highest amount of seismic unrest beneath its caldera since 1982 to 1984. So the Italian volcano in the Phlegrean Islands seeing a seismic storm not seen for decades. The possibility that Campe Flegrei is coming back to life. Suwanosejima is also producing an 8,000-foot ash plume there. That's in the Ryukyu Islands near Japan. Mount Mayan on Luzon Island, Philippines, produced an unknown-sized volcanic ash cloud. Please do not pole vault the caldera. Popocatépetl exploding. Flight level 240. It's a 24,000-foot ash plume over central Mexico. One of my bucket list volcanoes. Gotta go see Popocatépetl someday. Who knows? Maybe it'll become safe to go to Mexico. Fuego in Guatemala exploding, flight level 160. It's a 16,000-foot ash plume. Nevado del Ruiz exploding, flight level 220. 22,000-foot ash plume over Sangay as well in Ecuador. Revenador, 14,000-foot ash plume. Sabancaya, 25,000-foot ash plume over Peru as it explodes. And again, please do not pole vault the caldera. We don't want our viewers to become a portion of the lithosphere. It could be unhealthful to pole vault. If you're going on a volcanic vacation, leave your vault pole at home. Anyway, here's the past 90 days, and we've got high seismic activity as a 6.6 magnitude earthquake just happened in the Kermadec Trench earlier this morning. That is northeast of New Zealand there. In between New Zealand and Samoa, there's a huge trench called the Kermadec Trench, and then up here it's called the Tongan Trench, but it's basically the same feature. That quake was at depth, so it was very unlikely to have caused a tsunami. Otherwise, we would have sent out email alerts to the Smash Team at smashomash.com/Smash Team. Anyway, we'll call out quakes over a 5 magnitude for the past 24 hours, and indeed we're seeing some quakes around Cascadia there and around the northwest coast of the U.S. So, but no major quakes. We're not going to call them out. We only cite quakes of a 5 or greater magnitude, typically. So, Indonesia had a 5.1. That was also at depth. It occurred at 1920 Universal Time yesterday evening. The depth was 128.6 kilometers. Kamchatka had a 5.0. That was at 23:02, 58 minutes before 0 dark 100. Before 0 hour. 23:02, a 5.0 struck Kamchatka. And beyond that, recent seismic uptick just this morning at 9:09, a 6.6 strikes the Kermadec Islands. A 6.6 magnitude quake there at 9:09 and about 90 kilometers estimated depth, and a 5.5 only 19 minutes later strikes Japan. That was also at some depth there. So an uptick in deep quakes over the past 24 hours. And let's head back to space. So here we've put together the 211 angstroms plus 304 angstroms just to show something different. And if you see this M-class flare up here, there was indeed a coronal mass ejection, which caused that flare. And by the way, we'll talk later in the video about how CMEs cause flares and not vice versa. Who knew? Probably everybody that watched our channel regularly knew. And the 10.7 centimeter radial flux has moved up precipitously. Now, I think this might be an aroma. I'm not sure. Could be an erroneous reading there, but a big uptick in the 10.7 centimeter radio flux here. It's gone all the way from 141, I think it was yesterday, up to 161. So a precipitous increase in the radio flux. Well, it looks like it is accompanied by a big increase in the sunspot number, so maybe that's legit. 161 is the new number for the F107. The F107, as it's sometimes referred, the excited hydrogen in the upper chromosphere and lower corona. It comes out of this little thin area right here, the lower corona and upper chromosphere. So that's the 1 year graph of the radio flux, this black line. The red line is the sunspot number. Here's a space weather enthusiast dashboard, and NOAA's not predicting any significant space weather events. No CME impacts there on the forecast, and our forecast might include one. We'll show you some analysis about the most recent CMEs a little later in the video. First, Earth's magnetic moment from space for the past 4 hours. There is our geospace magnetosphere movie, and it is quite geomagnetically calm on planet Earth at the moment. And it was meteorologically not calm at all last night in Lehigh Valley, Pennsylvania. We got some crazy weather. Here are the past 4 hours of Earth's magnetic moment from the ground. Our ground magnetic perturbations map. And if you're worried about a pole flip, where are the quadrupoles? Where are the hexapoles? Where are the octopoles? This magnetic excursion is barely even a blip on the radar, geologically speaking. That's the past 4 hours, and things are calm indeed. I'm not spooked. Are you spooked? Let us know in the comments if you're spooked. Are you spooked of a pole flip? Because most of us don't think one's occurring, so I don't know why you're spooked, but whatever. Planetary K-index currently at 0.33. So very geomagnetically calm. And it has to do with low solar wind parameters. So here we're seeing a changing of the guard. So this is interesting in that you're seeing a very different plasma regime there as measured by the ACE spacecraft. So there are two spacecraft that we're typically using for the solar wind that orbit Lagrangian point 1. It's about 1 million miles from Earth, in between the Earth and Sun. So you're seeing a slightly denser plasma regime there, about 3.5 protons per cubic centimeter measured by the ACE, and only about 1 proton per cubic centimeter measured by the Discover. So just a great example of how filamentary the solar wind can be. And that's what's going on there. Different densities there being measured by the two spacecraft. Little CME impact here is very minor. More of a magnetic field event than indeed a major CME impact, but you see the changes in the plasma temperature, solar wind speed, solar wind density, and a little shift in the magnetic field at the same time there. Anyway, the current conditions are as measured by that's the Discover, barely 1 proton per cubic centimeter, not even 1 proton per cubic centimeter, and about 400 kilometers a second for the solar wind speed. So very diffuse and just a nominal speed. Pretty unremarkable there over the past 24 hours. GOES magnetometers here are chill. Those are pretty smooth curves there for the geosynchronous near equatorial GOES 16 and GOES 18 satellites. And next, the top view ecliptic plane field plot. And Earth is in a south pole current sheet. You can expect to stay there for the foreseeable future. Almost right in the middle of that south pole heliospheric current sheet there, depicted in red. Here is the line of sight field plot. The solar B field is depicted in blue. The B field is kind of like the field that goes through the magnet, this magnet being the sun. Polar fields are depicted in red for south and green for north. And then you've got the gong magnetogram there showing the photosphere's magnetism, which is indeed separate from the coronal magnetism, which now we're viewing. Here's our line of sight coronal hole plot. We've got some rather well-defined South Pole-oriented coronal holes. No surprise there to our regular viewers, as we have been seeing a shortage of coronal holes throughout this solar sunspot cycle. So let's take a look at coronal holes. Here is 211 angstroms, another 24-hour video there from the Solar Dynamics Observatory. So these are south. And we can expect an uptick in the solar wind from especially this one, as it is quite close to the equator. Transequatorial coronal holes are the ones most likely to cause effects on Earth, like little upticks, and sometimes they create significant geomagnetic storm conditions. So that'll be about 4 days out. We may see a little uptick from that. And just before that, we may see a coronal mass ejection impact. So some exciting stuff going on, and let's move to sunspots. Here's what's going on. A very high likelihood of solar flares is what's going on. So we've got multiple groups here in the northern hemisphere. This group over here, which is actually 2 sunspot groups, this group over here, and this group. All 3 of those areas are capable of producing major flares, including X-class flares. And at the moment, once again, a very high likelihood, according to magnetic shear, that sunspot 3241 will jump off with a large event. As it gets closer to the limit, it becomes more likely to happen. Let's take a look from SDO. So there is the past 24 hours showing SDO 131 angstroms ionized iron, as well as the SDO continuum. And again, the largest flare was from this area right up here. A very complex and spread out series of sunspot groups there. No really huge umbrae, but a great example of how you don't need huge umbrae for large solar flares. Here we've subtracted 131 angstroms to show just the continuum by itself. All right, that is a huge number of sunspots there in the northern hemisphere. I thought there was a little degradation. I think the radio flux number is legit. That is not from some sort of a transient, not from some sort of a transient event. That 161 radio flux is legit. So we'll also show the magnetogram while we're zoomed in on this equatorial view. There's a 24-hour SDO magnetogram. And these are the kind of things that make the Solar Dynamics Observatory my favorite telescope. The James Webb is pretty sweet too, but it's not going to look at the sun. It is infrared after all. And it would be a huge washout if the James Webb decided to turn its cameras at the sun. Moving right along to energetic particle layers. And we ain't got none. So energetic particles are baseline here. So no solar energetic particle events. The proton flux remains at base levels. These little dips in the X-ray flux you see, those are from lunar eclipses. When the moon gets too close to the GOES, or it gets in front of the GOES, you see these dips in the X-ray flux. It's not erroneous data. It is a lunar eclipse for the GOES. That is the GOES 16 and GOES 18. And again, the largest flare event of the past 24 hours was this M2, which occurred at peak flux was around 1910 Universal Time yesterday. Anyway, let's take a look at flares. There's 94 plus 131 angstroms. And it looks like we do have more active regions there rising over the eastern limb. So if you're one of these people who's mad every time there is a new sunspot group or something like that, sorry. I don't know what to tell you. If you have invested a lot of cash in the bank of grand solar minimum, you've made bad investments and you should pull your cash out immediately, because there is no grand solar minimum. This solar cycle might exceed solar cycle 23, which was quite a strong solar cycle. This isn't just not a weak solar cycle. This is a moderate to strong solar cycle, and it could rival some of the strongest ones in the modern age. So it's closer to a grand maximum than a grand minimum, folks. Facts. And we're nowhere near solar maximum, by the way. So it looks like Mercury has become a morning celestial body again here, rising ahead of the sun. We've got a moon up there over Lehigh Valley, Pennsylvania. Also Jupiter there, slowly setting across the ecliptic. That is our star chart for our location, skyandtelescope.org. If you want to make your own, just enter your zip code or enter your location manually and get your own sky chart if you like. Deneb, up there, the brightest intrinsic object visible from our solar system. And here comes a forecast for our solar system. And I'm spending limited time on the screen because my shirt is magic and it looks kind of weird. Anyway, here's your solar system forecast. We'll advance this 1 week. And in 1 week, we'll have the new moon, my favorite phase. If you're a wizard, you would know why. Are you a wizard? Are you engaged in sorcery? Well, you know, some spells are supposed to be cast at new moon, not full moon. What are you, an idiot? Pardon my sarcasm. And let's move on to the astronomy photo of the day. So this is M17. I don't know how I remembered that. The 17th entry in the Messier catalog. It's a, quote, star-producing and, quote, nebula. Why is it, quote, star-producing and, quote? Because it's got thick dust and X-ray producing areas. I won't hold my breath until we see a star form. However, I'll just leave it at that. Still a sweet image there from the Grand Mesa Observatory, courtesy of Kim Quick, Terry Hancock, and Tom Masterson. Let's do another little slow crawl here. If you want to make that your computer desktop, apod.nasa.gov is the astronomy picture of the day. We've got a couple articles to go over here, as the reason I do space weather is because I realized I had to do I had to do a deep dive into heliophysics because of what I learned and didn't learn when I took college astronomy in the mid-1990s. So there is I'll just say there's some new interesting information about how space works. I'll just say that. And if you're not familiar with Cepheid variables are one of the standard candles that we use to measure distances. So these variable stars, they pulsate in a known fashion, and their activity gives us an idea of the distance. So this is one of the ways that we calculate distances to things. And, you know, things that are very far away. It's very hard to calculate the distance to a galaxy, because galaxies are very varied and they vary in size. And there's not a lot of reference points in space, as stuff is very spread out. So if you want to read about Cepheid variables, there's a great article on Wiki about it. Guess what? There's a new way of measuring galaxy distances. How? Well, hydrogen to iron ratios in a different type of variable star known as, I don't remember what they're called, RR Lyrae stars. So that's a little bit of an advancement there. Pretty cool. Again, it is showing us the iron to hydrogen ratio of those stars. And metals are very important, by the way. In the realm of cosmology, we call everything more massive on the periodic chart than helium. We call those all metals. And it has to do with the concordance model of stellar evolution that I won't get into. The concordance model of stellar evolution. Cold lambda, dark matter, cosmology. I'm not going to get into that at the moment, as this is a daily space weather video. And of course, we regularly talk about how, I said it earlier, that solar flares don't cause coronal mass ejections. Coronal mass ejections cause solar flares. And guess what? This has been backed up by Caltech's laboratory. So here is a laboratory. That's not the sun, by the way. That is a banana-sized experiment at Caltech creating a thing just like a solar flare. So it has to do with the filaments and it's almost like a short circuit, folks. I'll just say that. The filaments are causing the flare. The flare is not causing the coronal mass ejection. In other words, when the filament reorients itself, those X-rays are produced. So tell your friends and foes that solar flares don't cause coronal mass ejections. Coronal mass ejections cause flares. As we've been saying for years, shout out to Eugene the Philosopher. Go make sure you subscribe to his channel if you haven't. Eugene the Philosopher. Yes. Because there's plausible physics to explain why a coronal mass ejection would cause a flare, but not why a flare would cause a coronal mass ejection. And chicken and egg arguments matter in science, especially in physics. So, if you weren't aware, by the way, we sent out an email to the Smash team about this. You would have already found out about it if you would have become a member of the Smash team, signed up for email alerts, etc. Smashomash.com/Smash team. We provide additional content, especially to Gold Smash team members. And by the way, we're writing a paper that explains the mechanism underlying the solar sunspot cycles. It's pretty serious. Because why? Well, in science, a lot of times we end up with answers to questions not asked, which is what's happened to me, so I've got to act on that and submit a paper for peer review. It's kind of serious. Shout out to Dr. Pierre-Marie Robitaille, who it wouldn't have been possible without, as well as, again, Eugene the philosopher. And let's move on to coronal mass ejections. And there have been a number of them. So here is yesterday's 100 frames from George Mason University. And I don't think the CMEs that we're seeing here yesterday, there is one that looks like a halo right here. There's one that's showing up on all sides of the coronagraph. I don't think that's earthly directed. I think that is actually on the far side of the sun. However, today, much more recently, I think there may be an earthly directed CME, although it is very diffuse and stealthy. Sometimes when they're headed directly at the coronagraph, it takes a long time for them to diffuse enough to appear as a halo. So I think there may be one on the way. It would arrive sometime late in the day on the 11th. So on 9/11, sometime after noon Universal Time, we may see a CME impact. If so, it will be minor. So it's not really anything to be alarmed about, certainly. And keep in mind, CME impacts, coronal mass ejection impacts, they do vary based on things like magnetic field strength and orientation. Not just the density and speed of them, but magnetic field strength and orientation is a huge factor in how CMEs show up. So now we're showing LASCO C2 and C3. The last imagery was just LASCO C2 and some difference imagery there. Here is a little closer view. And if we bring this to the latest image, so lots of CME activity here, and the potential for more is certainly there as well, because we've got so many huge plasma filaments on the Earth-facing portion of the solar disk, especially that one in the southern hemisphere, one of the largest and densest plasma filaments we've ever covered on the channel. Now, we'd show you some more from Stereo A, but it's not particularly helpful right now. The data's a little bit on the old side, and it's just not so good. So we'll just skip that for now, and we'll cut to our custom coronagraph images. Here's a 24-hour video featuring the SDO 193 angstroms, along with the SOHO LASCO C2 and C3. And oh, check it out, we got a comet here too. Right down here, little comet there, unexpectedly showing up, as they've been known to do. It's just one of those things, if you're not looking, you're definitely not going to see it. Right up here. Right there it goes. And it looks like it has disintegrated there as it moves into the LASCO C2. Let's see if we can even see that. I don't see any hint of it there on C2. It looks like it has broken up. Now the CME that may be earthly directed, it's right at the end of this. You'll see a little scintillation right down here. Again, if that's going to strike Earth, and it might, expect that sometime after noontime Universal Time on the 11th. The 11th of September. So I wouldn't expect that to go above a KP6 if that is an earthly directed CME. So yeah, so right in there. Now keep in mind also, folks, that sometimes something happens on the far side of the sun, which is also represented on this side, so it can be a little bit confusing. And without stereo A having a better angular position, it's very hard to calculate CME trajectories. So it's not only hard to determine what their speed is, it's also hard to determine where they're headed, period. So that is an issue. Fortunately, stereo A is moving out to the west, and things will improve with that. Next, we'll look at filaments and check out there are two massive filaments especially here. This one here is just ridiculous. And that one definitely deserves a name. We're going to name that filament today, if nobody else does. And if you want to name filaments, do it over on Twitter. More on that in a minute. First, the grayscale here, since it shows prominences. So there's the prominence situation as well as filaments. They are really the same feature. A prominence is just a filament that's hanging off the limb, like this crown prominence or this one over here in the northwest. Wow, very high likelihood of solar flares here in the northern hemisphere. That is the environment that you would expect to see an X-class solar flare, folks. So, and check out the size of this filament. I think this whole area here is a filament. I don't think that's two. I think that's one filament. That is absolutely gigantic. Very, very dense. And we hope you're dense. We hope your brain is dense, because that's associated with being smart. And if you want to name that filament after living humans, it can be a brain-dead living human, but they have to be technically alive as per the medical definition, meaning having a heart rate and brain activity. I don't mean literally brain dead. Well, you get the idea. Anyway, if you want to name filaments after living people, do it over on Twitter. Don't do it in the YouTube comments, because it's going to be ignored. You have to go follow over on Twitter. How about getting us to 500 followers? Geez, we've only been doing this since 2019 and being censored the whole time on the pathetic junkware platform, which is no better than Meta or Google-based platforms. Free speech has been restored on the internet by Elon Musk. These are the words of a sycophantic, delusional fool. Cheers. So yeah, name filaments after living people. We've got some ideas. We're definitely naming 2 filaments today, if you don't in the meantime. And if you've unplugged entirely from social media, I don't blame you, because it's truly pathetic. As rich, famous, boring people with stale ideas are promoted, while people's businesses falter because of unnecessary, un-American, evil, ridiculous, nonsensical, anti-human censorship. Here are the past couple of hours from the GOES 16 SUVI, and you can see that crown filament, that crown prominence, which is a filament, by the way, looks like it's collapsing there. If there is any material there ejecting, it is not a lot of material. Also, you can see activity coming up over here. So yeah, likely new regions forming. And let's get to our bonus feature segment. We don't want the video to be too lengthy, as we do indeed cover a lot of information. So here is the surface chart. Here's the charging scenario for satellites. And there are no charging hazards. It's smooth sailing. Here is the GOES electron flux measured at the F layer of the ionosphere using radiography by the geosynchronous near equatorial GOES 16 and GOES 18. We are just in a normal operating range here, below warning levels, just in a nominal range. Here is the 1-year chart to put it in context for you. You can see right there, moderate levels of electron flux. There's the forecast, expecting a dip in the electron flux here in the coming days. Okay, that's NOAA's forecast for the relativistic electrons at the F layer of the ionosphere. We'll also show the vibrational frequency of that layer. Feel free to pause the video on this frame. The F layer, it's at about 300 kilometers of altitude. And a little bit more about that. It does change throughout the day and night. So in the daytime, the ionosphere is much more heavily ionized because of incoming solar radiation. And it actually splits into multiple layers. It gets scintillated. It gets excited by that incoming solar radiation. And so you've got, the D layer and the F and F2 layers and so on. That's another photo there, courtesy of Wikipedia. And here is the vibrational frequency of the F layer. And things are quite normal here. There's really nothing to comment on. And once again, back to the pole flip. If there was a pole flip going on, this would look very spooky. It doesn't. It looks very normal. So there's that. You can barely call what's going on planet Earth a magnetic excursion. It's, from a geological perspective, it doesn't really even qualify. The fields are not weak enough. Anyway, here's the latest image, 10:45 Universal Time. Anomalogram, there's the ionogram. Sorry, the world's not ending. If you wanted the world to end, it's our apologies, as things are just fine. Our finest days lie ahead. Space isn't going to kill you. Period. Deal with it. Here's the electron content forecast. Feel free to pause the video on this frame if you're not familiar with these distances in miles. This is literally a count of free electrons from the ground level up to your GPS satellite, which is located about 12,500 miles of altitude. And guess what? We are seeing some anomalies in the electron contents. Now, these are probably Earth-based signals, because keep in mind, folks, the Earth has its own magnetic field, which interacts with those incoming solar particles. Also, keep in mind that most of the material in Earth's Van Allen belts is earthly material, like the electrons and so on. So anyway, like I said, we are seeing some significant electron content anomalies here over Cascadia, right in there. See that? Vancouver Island, British Columbia, the west coast of Canada, also Mexico, Central America there, seeing some high electron content anomalies. That is the total electron content anomaly from the 10-day average. A much higher resolution view than the world view that we showed. As we zoom in closer and closer to Earth's weather, we're going to close out the space weather section of this video, as we do with the latest intensitygram and latest magnetogram. So, this sunspot, very magnetically complex. It is capable of producing X-class flares. It does have the kind of filaments around it that you would expect to reorient themselves, causing the large flare. That's beta gamma delta class as well. Another likely spot to see a large flare. And this is the biggest flare player over the past 24 hours. This group up here, also beta gamma delta class. So 3 massive sunspot groups in the northern hemisphere there. All 3 are the most likely class to produce large solar flares, beta gamma delta. And what do you say if we go to meteorology? What do you think? Shall we talk meteorology? Okay, I think there's certainly some interesting stories when it comes to meteorology. 2 hurricanes there, one in the Pacific, one in the Atlantic, and the world's largest waves are right in this area, I think. Although this Atlantic hurricane is intensifying, so when we did show prep, we actually saw 40-foot waves in here. Looks like that might be calming down a little bit. The waves over here, not quite as large. So, but still some stormy seas there. Those are not optimal places to be sailing. And we're going to show you some forecasts here. Southern Ocean is quite scintillated as well. And let's take a look at earthly weather. So here are the surface winds of the east. Multiple low pressure systems there around Australia. Also around Kamchatka, the Siberian coast, etc. Here are the jet streams of this side of the world. And the South China Sea there and the Indian Ocean featuring a backward jet stream. Here are the jet streams of the central world. Surface winds. Surface winds of the west. And jet streams. We've got a jet stream divergence over the central U.S. And let's move on to look at this Atlantic hurricane, as it is definitely the source of a lot of conjecture and coverage. So we're going to advance this 3 days to show the Euro forecast. There's where we expect that to be on Monday at 9 o'clock Eastern Time. or 1300 Universal Time if you prefer, a major intensification as forecast as it moves over warmer and warmer water. That's the Euro forecast. Here's the GFS forecast as another tropical system forms way off to its east. So again, there's the GFS forecast for 9 a.m. on Monday morning. And there's the Euro forecast for 9 a.m. And it looks like the predicted winds there are like Category 4 hurricane level winds. Keep in mind, windy.com does show kind of lower winds than might actually be expected to happen. The GFS forecast not expecting as significant of an intensification there as the Euro forecast. But they're going to be in the very similar location there. And let's move on to look at clouds and fog. As the sun rises over the eastern U.S., so there is clouds and fog, and here is a close-up of that hurricane. So you can see it disintegrating there a little bit, the eye wall breaking down. Don't expect that to last. It's going to likely reform as that's moving over warm water, like 86-degree water. Next, your weather.gov map. Here's the key. Get your weather warnings from weather.gov if your location is lit up on the map. Those are too many counties to cover. Mostly excessive heat warnings on the map. And I don't know why I've got the marine forecast. I didn't do anything with that. Here's our smoke map. And there is indeed some smoke there rolling down from Canada. It's not as extreme as the previous days. And let's do some forecasts. So first, the GFS 72-hour pressure and precipitation forecast for the Atlantic. There is the GFS storm path there. Again, certainly intensifying. You can see the pressure dropping there down to 944 degrees. So it's looking like it's getting a little weaker than yesterday's forecast. But still, 940 millibars is certainly a low pressure indeed. Major hurricane. And here's a GFS forecast for the lower 48. Strongest weather will be in Kansas within the next 3 days. It doesn't look like it's that extreme, and let's move on. As we've got the lightning mapper, and man, we had some serious storms. I believe there was some tornadic activity yesterday in Pennsylvania, some hailstones, certainly some major thunderstorms, and it was interesting indeed. And let's check our real-time lightning map here to see if we have any terrestrial strikes. And indeed we do have some terrestrial strikes in western Arkansas. Pretty significant storms there, especially the one to the northwest of Hot Springs. With that many lightning strikes, you could expect that storm to be accompanied by damaging wind and hail. Next time you say what the hail is going on with the lightning, check out lightningmaps.org. It's highly recommended. It could save you. Like literally, save your life. Hopefully giving you life-saving advice won't get this video demonetized by the anti-humanist agenda of certain big tech organizations. So don't forget to press subscribe and maybe, I don't know, sign up for email alerts at smashomash.com/smashteam. That might be wise, as you'll get email alerts about videos just like this one instead of relying on certain very untrustworthy organizations. Press that subscribe button, press share, leave a comment, and don't forget to tell your friends and foes about the channel. What in the heck? And by the way, thanks to our new subscribers. Once again, congratulations on realizing the channel exists. We're going to close this video out with U.S. Doppler radar. There's the full 50-state view. We're going to mainly focus on the lower 48 view. There's the zoom we want. Some heavy weather there, making its way across Arkansas. Here is clouds and fog for the same region, the lower 48, and here is water vapor. And check it out, you've got a great example here of constrainment and collision. You've got massive high-pressure air over here, massive high-pressure colder air down here making its way down, and kablooey. X marks the spot of massive pressure gradients. It's like an atmospheric waterfall that happens as that moist air cannot sustain all that dry, massive air, and you get a lot of vertical motion in the air column and heavy metal weather. So that's what's going on. There's the lower 48. This is your recap to close out the video. Don't forget to leave a comment. Don't forget to press the like button, as the algorithms hate facts. Yeah, facts are really controversial in 2023. There's clouds and fog. And there is the water vapor. Check it out. There's an upper level low here over southern Georgia. You can see this really obvious counterclockwise rotation. However, it's pretty dry there, so there's not a lot of stuff happening. But this warm, moist air in the Gulf, right in here, is indeed creating some rapidly forming systems there off the coast of the Florida Panhandle. Anyway, thanks for tuning in. Congratulations on realizing the channel exists. We'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.